Good morning, friends. In this session, we will see inverse Laplace by derivatives. In previous lectures, we see some examples of partial fraction method for inverse Laplace, convolution method for inverse Laplace, and divide by s for inverse Laplace examples. Some examples like log and tan inverse can be solved by only inverse Laplace derivative method. If Laplace of, as we know that, if Laplace of TFT, then right side we will differentiate Laplace of ft, that is phi of s, one time by s. So Laplace of TFT equal to minus derivative of phi of s. Now, therefore, we can say that inverse Laplace of derivative of phi of s is equal to minus TFT. So, we will use this concept in this examples, this type of examples. First, we will take the first example, log of s plus a upon s plus b. So, phi of s is equal to log of s plus a upon s plus b equal to log of s plus a minus log of s plus b. Now differentiate both sides with respect to s, because we don't know the inverse Laplace of this part. But if we differentiate this one, that is phi dash s equal to derivative of log of s plus a minus log of s plus b. Therefore, phi dash s equal to 1 upon s plus a, which is the Laplace derivative of log s plus a. That means derivative of this part is 1 upon s plus a, and derivative of this part is 1 upon s plus b. Now taking the inverse Laplace both sides, the inverse Laplace of phi dash s equal to inverse Laplace of 1 upon s plus a minus L inverse of s plus b. Now these two inverse Laplace are known. This is the Laplace of e raised to 8 minus 80, so its answer is e raised to minus 80, and answer of this part is e raised to minus bt. Now inverse Laplace of phi dash s equal to minus tft, as we know according to this formula. Therefore, inverse Laplace of phi dash s equal to minus tft equal to e raised to minus 80 minus e raised to minus bt. Therefore, inverse Laplace of phi dash s equal to minus tft equal to e raised to minus 80 minus e raised to minus bt. Now multiply both sides with minus, then we get ft equal to e raised to minus 80 minus e raised to minus bt upon minus t. That means e raised to minus bt minus e raised to minus 80 divided by t. The final answer of this function, L inverse log of s plus a upon s plus b is equal to e raised to minus bt minus e raised to minus 80. Let us see second example. It is similar type of above example. Log of 1 plus omega square upon s square. So therefore, phi of s will be log of 1 plus s square upon a square. That can be written as log of s square plus omega square upon s square. And phi of s now written as log of s square plus omega square minus log of s square. This 2 is come over outside, then phi of s equal to log of s square plus omega square minus 2 log of s. Now we don't know the inverse Laplace of this part, so we are differentiating both sides with respect to s. Now taking the derivative both sides in the part phi of s equal to log of s square plus omega square minus 2 log of s, differentiating both sides with respect to s, we get phi dash s, phi, that is derivative of phi of s divided by s, is equal to, what is the derivative of log of s square plus omega square? तो 1 upon s square plus omega square into derivative of this part, that is 2s. So I am writing 2s here. Log of derivative of log of s square plus omega square equal to 2s upon s square plus omega square, and derivative of log of s is 1 upon s. That means this part derivative is 2 by s. Now taking the L inverse both side. Here we are taking L inverse both side. So that is, this part is a derivative of phi of s, and taking L inverse, that means inverse Laplace both side, we get L inverse of 2s upon s square plus omega square minus 2 by s. Now we know both the Laplace. In this step we are not knowing inverse Laplace of this part, but now we know the inverse Laplace of both the functions. So we can apply the inverse Laplace right hand side, 2 common outside and cos omega t, and here 2 common outside, 1 upon s is a Laplace of 1, so this is only 2. Now in the left hand side it is inverse Laplace of t, inverse Laplace of phi of s. That means it will be minus tft, because t multiplies 1 times. Therefore our function is minus tft equal to 2 cos omega t minus 2. 2 common and divide by t, we get ft equal to 2 cos omega t minus 1 by minus t. That means final answer of L inverse log 1 plus omega square upon s square equal to ft equal to 2 cos omega t minus 1 divided by t. Here we have a minus. So that is our final answer. Let us see the two more examples for self-study. Log of s plus 3 upon s, so that can be written as log s plus 3 minus log s, and its answer is this. Please try it. Similarly, this is also similar examples as above, so I think here we have a minus. So now this is our method for inverse Laplace by derivative. Let us see one more example. L inverse of cot inverse s by 2, or it can be also written as L inverse of tan inverse 2 by s. So here phi of s equal to tan inverse 2 by s. Also we can take this function cot inverse s by 2. Therefore phi dash s, because we don't know the inverse Laplace of this function, but after derivating it is known. So differentiate both sides with respect to s. Differentiating with respect to s both sides, so what is the derivative of tan inverse s? So tan inverse s, derivative of tan inverse s is, here I am writing the derivative of tan inverse x dx equal to 1 upon x square plus 1. So I am applying this formula here. So 1 upon s1 plus s is x square, and now derivative of this part 2 by s. So what is the derivative of 2 by s? 2 by s derivative is minus 2 upon s square. Now simplify this part. So taking the LCM in this denominator, s square plus 4, s square goes to upside, s square cancel. Then final answer is phi dash s equal to minus 2 times s square plus 4. Now L inverse of phi dash s equal to minus L inverse of 2 upon s square plus 4. Now we know the Laplace of this part. This is the Laplace of sine 2t. So this side will be minus sine 2t, and this is inverse Laplace of derivative of phi of s. That means inverse Laplace of phi dash s equal to minus tft equal to minus sine 2t. Therefore ft equal to Sine 2t minus minus cuts from the both side. Therefore, our answer of this function equal to cot inverse s by 2 equal to tan inverse 2 by s equal to sine 2t by t. Let us see one more example. L inverse of log of s square plus 9 square under root of s square plus 9 upon s square plus 4. Here we remove the square root. It is power of, it is a log of s square plus 1 upon s square plus 4 raised to 1 by 2, and this 1 by 2 goes to outside. So finally phi of s will be 1 by 2 log s square plus 9 upon s square plus 4. Now phi of s equal to 1 by 2 log s square plus 9 minus log s square plus 4. We don't know the inverse Laplace of this part, but after differentiating we know it. Okay, so differentiating both sides with respect to s, this side is phi dash s 1 by 2 sz is derivative of this part is, what is the derivative of log? So log derivative is 1 upon x, so it is 1 upon s square plus 9, and derivative of s square plus 9 is 2s, so this is the derivative of log s square plus 9, and this is the derivative of log s square plus 4. Now 2 common and cancel with this 2. Phi dash s equal to s upon s square plus 9 minus s upon s square plus 4. L inverse of phi dash s equal to L inverse of s upon s square plus 9 minus s of s square plus 4. In this case, we know both the inverse Laplace. Inverse Laplace of this part s upon s square plus 9 is cos 3t, and inverse Laplace of s upon s square plus 4 is cos 2t. And this side is inverse Laplace of derivative of phi of s, so it will be minus tft. So finally divide by t. After dividing by minus t, we get ft equal to cos 2t minus cos 3t upon t. Let us see one more example. L inverse of cot inverse s plus 1. Here phi of s is equal to cot inverse s plus 1. So phi dash s is, differentiate both sides with respect to s, derivative of cot inverse s plus 1 with respect to s, as we know that derivative of cot inverse x dx equal to minus 1 upon 1 plus x square. So here I am taking minus 1 upon s plus 1 whole square plus 1, that this is our x. Now apply inverse Laplace both side. Inverse Laplace of phi dash s is equal to minus, over outside, inverse Laplace of phi dash. Here this is the Laplace of sin t with shifting property, because s is replaced by s plus 1. So inverse Laplace of this part is e raised to minus t sin t, and left hand side is minus tft. This is inverse Laplace of derivative of phi of s. Minus minus cancel from the both side, and ft equal to e raised to minus t sin t divided by t. L inverse of cot, therefore L inverse of cot inverse s plus 1 equal to e raised to minus t divided by t. So I am giving you one more example for the self study. L inverse of tan inverse 1 upon s minus 3, and its answer should be e raised to 3t sin t upon t. So in this session we seen inverse Laplace by derivative. So when your examples is like in terms of cot inverse or tan inverse or log, then we will apply this only this method for the inverse Laplace.